So that came that came into existence. And when I first started getting into EMC, they were the kind of the only standards more or less out there. It's kind of interesting if you think about mill standards with respect to commercial standards that I'll talk about in a little while. The mill standards are not legal requirements. They're contractual requirements. You don't have to meet the mill standard. Of course, the military may say, you want to sell me an airplane, you do. So, well, that's a contract between the military and you. You don't want to sell them an airplane, you don't have to what? Meet the standards, you know. Whereas, legal standards are the speed limit on the road out there is 55 miles an hour. That applies to all of us irrespective, okay? And we can't get around it, okay? That's the legal requirement. So the mill standards are contractual requirements and not legal obligations. And the 461 series started with revision A again in 1967 through F, which is the current version in 2012, and G should be out shortly, I guess. They're working on G right now. Now in 1999, I guess, Mill Standard 461 and 462 were merged into one document, which was just 461. So the 461 E version merged those two together. So now there's no longer 462. The test procedures and the limits are combined in the same standard for 461. And as I say, 461, when I originally put this presentation together, I had said 461G was coming along shortly, and that's the case here. One of the things they're talking about possibly being in it that is not in any of the present one is some indirect lightning tests. A lot of these changes to the standard are fairly minor, and sometimes every once in a while they throw something in that's kind of major. So you gotta keep an eye on it and see what the heck is going on there. So okay. The other thing is EMC problems can sometimes have serious or hazardous consequences. I got a couple examples just to throw out because a lot of people say, well, yeah, you got to meet them, the standards are there, but, they're just something I have to do, and is there really a fundamental reason why this is really necessary? I would throw out two examples that I'm aware of, both kind of military, naval type equipment. And that's the story of the USS Forrestal and the British ship, the HMS Sheffield. In 1967, during the Vietnam War, the Forrestal had a big fire on the deck, killed 130 some odd sailors and airmen. Investigation that sort of what it was, a whole bunch of aircraft, of course, sitting on the deck waiting to take off. And for whatever reason, the radar on one aircraft scanned across another aircraft, and due to an improperly terminated connector, the radar signal coupled into the signal and fired a missile off the aircraft. Not good to fire a missile sitting on a deck of an aircraft carrier with other aircraft all around you, okay? And that hit an external fuel tank on another aircraft. Worst situation, okay? And tremendous fire. I'd say 134 people were killed because somebody didn't terminate a connector right. Or whether it was the design or the build on that one, I don't know that much detail. But the point was, here's a case where loss of life, et cetera, so because of an EMC problem. So it can be more than a nuisance sometimes, EMC to us. The other one I like to tell a story of is the HMF Sheffield. If anybody remembers back in 1982, the Falkland Islands War, the Sheffield was sunk by an Argentine aircraft. Now, this was an interesting story of an EMC problem plus coincidence, okay? The way the British fleet communicated with the homeland, which was quite a ways away from Argentina, was via satellite communication. And the Sheffield had either information to send or receive, I don't know. So they wanted to communicate back to Great Britain. And there's a compatibility problem on this ship that the radar interfered with their satellite communications. So during the period of time that they were going to communicate with Britain, they turned the radar off. As Murphy's Law would have things, just about that time, an Argentine fighter comes out to the fleet, okay? And with all the electronic countermeasures that exist on aircraft today, he knew that he was not detected on radar. So he's going to launch a torpedo at the ship. But since he knew he was not detected at radar, instead of launching it, I don't know, 30 miles out or whatever the range is, he came in extremely close to the ship. Because nobody sees me, he's got no radar, he feels safe, he comes in extremely close to the ship. Launches a torpedo very close to the ship. Torpedo hits the ship and it's a dud, it does not go off. But with all the fuel it has in its tank, because it hasn't used the fuel because he launched it so close, the fuel set the ship on fire. So a dud torpedo sunk the ship. So it starts with an EMC problem and then this crazy coincidence. If he had launched it way back where he normally would have, it probably would have just put a dent in the hull, and that would have been the end of it, because it wouldn't, would have burned most of that fuel. The Sheffield also had an aluminum deck, and if you get aluminum hot enough, aluminum will burn. And you put the whole thing together, and it turned out to be a disaster again with loss of life. So sometimes these EMC problems can be very, very serious. I know most of us just luckily don't have problems that serious, but they can be under some circumstances. So we have to worry about that.